Okay, so in part 2 of section 1.2, let's explore another couple of methods. The second method, so this is method 2 on the handout, is the square root method. You're going to like this method because it is really fast. It is very limited, though, is its problem. You can only use it when you have a template. So this is what we're following. So this method only works when you have x squared equal to a constant. So again, something squared equal to a constant. So as our first example, this is example 2a, we're going to go solve x squared equals 36. So notice, yes, indeed, we have x squared and we have a constant. So literally all we're going to do is take the square root of both sides. That's going to give me x is equal to the square root of 36, which is 6. Okay, and we have two problems here. The first issue is we know that this is a quadratic equation, so we should have two answers. These are not repeated real solutions, because if I tried to factor this, it would not factor in two identical factors. What we are going to notice instead is that when we square root 36, it could either be a positive 6 or a negative 6. So what we're saying is if we take a negative 6 and square it, we would get 36. And if we take a positive 6 and square it, we get 36. So I was just checking the solutions of what we were doing. So in general, we look at the principal square root, which is a positive 6, but when we're solving, we need both of them. So we get two answers, positive and negative 6. Negative 6, positive 6. Okay, there's a second example here I want to work just to show you that it doesn't always come out as a nice, beautiful answer like plus or minus 6. So this time we have the quantity x plus 3 squared is equal to 28. This still fits our template because we have a square on the left side, a constant on the right side. We can still come in and just square root both sides. Square root, that's going to give me x plus 3 is equal to plus or minus the square root of 28. And we have to clean that up. We can't leave it like that. So we need to solve for the x by moving the 3. I'm going to put that negative 3 when I bring it over in front of the radical because it just looks prettier there. The other issue we need to do is simplify the square root of 28. Well, 28 is 4 times 7. The square root of 4 is 2. I cannot square root the 7, so I'm going to inside, and there it is. And those are the exact answers. Notice that one solution, I tend to write them in this way, but one solution is negative 3 plus the square root of, 2 square root of 7. The other solution is negative 3 minus 2 square root of 7. So there's my two solutions for this. So the square root method is quick. It's fast. It's easy. I can use it anytime I have a square and a constant. But it's really limited because if I had that middle term, that bx term, I could not use this method. So somewhat limited. But it does lead us into our next method. So method 3 on the handout is called completing the square. This method's going to work no matter what. It's a beautiful method. It is wonderful to be able to do it. The difficulty or the disadvantage is that sometimes it can get complicated and involve fractions, which you tend to not like. So and then 3 square. Comment about this is that we will use this method in later chapters, so we have to learn it, and learning it now saves us some hassle later on. We'll need it when we go to graph circles and parabolas in later chapters. So for our equation we're going to solve, this is example 3, is x squared plus 6x minus 2, and that's equal to 0. Okay, so notice it's already in standard form. So square term first, dx, and then c. What we're actually going to do this time is we're going to move the constant. Constant to right side. Okay, we can do that. So that'll give me x squared plus 6x is equal to 2. Now we're going to come in and do the actual completing the square. So we're going to complete the square. So to do this, the first thing we're going to do is we're going to take half of the x coefficient. Now I'm going to do it as scratch work just so we can keep track of it. So the x coefficient is 6. I'm going to take that 6 and I'm going to cut it in half. So half of 6 is 3. And then going to square this result. Square this result. So I'm taking that 3 and I'm going to square it. It's called completing the square. So 3 squared is 9. Now what I'm going to do is add that to both sides. both sides. Okay, so when I rewrite my equation, I've got x squared plus 6x plus 9 is equal to 2 plus 9. So in other words, you can do whatever you want as long as you do it to both sides. So I added 9 to both sides. I maintained the equality of that equal sign. We're now going to factor the left side. Factor side. So now we're looking for factors of 9 that add to 6. Well, factors of 9 that add to 6 are 3 and 3. Believe it or not, that's the number that we got over here. And on the right side, we'll just combine them. 2 plus 9 is 11. So factor left side, combine right side. Okay. So I'm going to rewrite this into a little bit friendlier format. So isn't that x plus 3 quantities squared equals 11? Yeah, and now we're going to finish using the square root method. So now we're going to solve by square rooting using square root method. We'll just square root both sides. It's going to give me x plus 3 is equal to plus or minus the square root of 11, which I can't simplify. We'll move the 3 over and call it. So our end answer is x is equal to negative 3 plus the square root of 11 and negative 3 minus the square root of 11. And there it is. So let's walk through it again just to make sure we've got it. So the very first thing we did is we moved the constant to the other side. We then completed the square. To do that, we took half of 6. We squared that, which gave us 9. Again, half of 6 is 3, squared is 9. We're going to add that to both sides. We then factor the left side. It factors into x plus 3 quantity squared. It will always be a quantity squared, always, because that's what you did when you completed the square. That's equal to 11. We're going to square root both sides. That gives me x plus 3 equals plus or minus the square root of 11. Then we moved over the 3. So x is equal to negative 3 plus or minus the square root of 11. And that gives us our 2 answers. And that's completing the square. It's a very handy method, but you can also see right off the bat that if there had been a coefficient on this, like, I don't know, 5, the very first step we would have had to have done would have been to divide every term by that coefficient. So we would divide by coefficient on x squared. The difficulty is that, yes, indeed, that would have given me a 6/5 right here, which I then have to cut in half and square. You tend to not like that. It works really great as long as that coefficient on the term is a 1. It's a little uglier, but you should be able to do it. And that's our third method called completing the square. It always works, but it gets ugly. So we need something that's going to work, but doesn't get quite as ugly with those fractions. And that's a quadratic formula. And that's in our next